There's one last rule that's really important when it comes to triangle congruence, and that's something called, sounds a little bit like alphabet soup here, but it's called Cpctc. Okay, so we have to talk about what that stands for. What it stands for is corresponding parts of congruent triangles are congruent. So it's just a shorthand. Instead of having to write out corresponding parts of congruent triangles are congruent every time, we can just say Cpctc. And that's useful. If we can show that two triangles are congruent, then we can use that to say that a particular pair of sides or a particular pair of angles that we want to show are congruent are, because they're corresponding within the triangles that are congruent. So let's look at some examples of that. We'll start with something called the isosceles triangle theorem, which basically says if you take an isosceles triangle, like the one shown here, and you bisect it, cut it in half with a perpendicular line, a line perpendicular to the base, then the angles, in this case angles B and C, are congruent. Alright, so let's see if we can figure that out. We always start with what we're given. So if we're given that AC equals or is congruent to AB, I'll write that, AC congruent to AB, that's given. Okay, and AD is congruent, I'm sorry, not congruent. AD is perpendicular to CB. This upside down T sign means perpendicular. Okay, well, if they're perpendicular, if this line and this line are perpendicular, that means that the two angles where they meet have to be right angles. This is a right angle, and so is this. Okay, so our next line is going to be to say angle CDA and angle BDA are right angles. Okay. You can see the reasoning for the next step says all right angles are congruent. Okay, well, so what we're going to say here is that angle CDA is congruent to angle BDA. If they're both right angles, that means they're both equal to 90 degrees, so they have to be the same. They're congruent. All right. So we have now an angle, and we have, well, and we have the hypotenuse or a side, depending on how we end up looking at it, okay? So we've got that. Then we can also say that side AD is congruent to itself. So AD is congruent to AD. That's by the reflexive property of congruence, where we can say that anything is congruent to itself. So then we can say that triangle CDA is congruent to triangle BDA. And we can say that a couple different ways. We can either, well, let's think about it. We have an angle, we have a side, and we have a side. That's SSA, but we know that that does not work. It's not a valid test unless you have a right triangle, which we do. So we're not going to consider this a side. We're going to call this the hypotenuse, and this in here is a leg. Okay, so this meets the criteria for hypotenuse leg congruence. We have two right triangles, their hypotenuses are the same, and they have a leg that's congruent. So we can do this by HL. Please remember that SSA is not a valid test of congruence unless you're talking about right triangles and you have a hypotenuse and a leg. Okay, so now that we know that those two triangles are congruent, let's match up, make sure that we're talking about the right angles. C is first in the congruent statement, and it matches up with B. It's first in the other one. That's true. D is congruent to angle D in both triangles, both right angles, and angle A, this angle has been bisected, and those are congruent. So, all right. So we have our congruent statement set up correctly. If that's true, then we can say that any part we want out of that triangle is congruent to the corresponding part in the other triangle. So if we want to say that angle C is congruent to angle B, that this angle is congruent to this angle, we can do that now. We can say angle C congruent to angle B, and all we have to do is say Cpctc. Corresponding parts of congruent triangles are congruent. We'll do a couple more. Okay, if we're given that AD is congruent to CB, I'm just going to go ahead and mark that. AD is congruent to CB. Sorry, that was already written. All I have to write is given. Okay, and we're also told that AD is parallel to CB. It's always a good idea to just go ahead and mark these things on the diagram as you figure them out. Okay, and that's also a given. All right, now, they say the next step is to say DAC is congruent to BCA. DAC is this angle right here. They're saying it's congruent to BCA, so that's that angle. Well, can we say that? Yeah, I think we can, because we have two parallel lines and a transversal. So those two angles are alternate interior angles. And we know that alternate interior angles are congruent. All right, then we say AC is equal to AC. Well, that's just the reflexive property again. Reflexive property. So then, can we say that the two triangles are congruent? That ABC is congruent to CDA? Yes, we can. We have an angle and sides on either side of it. So we have, let's see, a side, an angle, and a side. So we can say those two triangles are congruent by SAS. Once we know that they're congruent, we can say that any part of them is congruent to another part. So I can now say that this line, AB, has to be congruent to this line segment, DC, because corresponding parts of congruent triangles are congruent. Done. Okay, one more. Always start with what you're given. So we know that OP, so this line, OP is congruent to OR. That's a given. We also know that angle Q is congruent to angle S. That's a given. All right, next up, we can say that POQ, that's this angle right here, is congruent to ROS. That's this angle right here. We know that because they are vertical angles. They're right across from each other on the intersection. And vertical angles are congruent. All right, now we've got everything we need. We've got an angle, we have another angle, and we have a side. Remember, if you have two angles and a side, it doesn't matter whether the side is in between the two angles or not. All it does is say whether you're using ASA or AAS, but they're both perfectly valid. In this case, the side is not in between, so we're going to write it with the side not in between and say AAS. Makes those two triangles congruent. Let's make sure things are in the right order. POQ. POQ is congruent to ROS. Yes, those are in the right order. All right, so once we know that they're in the right order and that we've got our congruent statement, we can say that any part of the first triangle is congruent to the corresponding part of the second triangle. So we can say angle P is congruent to angle R by Cpctc. Corresponding parts of congruent triangles are congruent.